Hi guys, in this video we're going to talk about gram to gram stoichiometry. It is the same kind of stuff that we've been doing, it just is combining all the stuff that we've been doing. You're going to need to know how to find the molar mass, you're going to need to know how to go from grams to moles and moles to grams, and you're going to need to know how to do mole to mole stoichiometry, and all this does is combine all those things. So we're going to get started with some Cornell paper. Here's mine. The first thing you need to do is fill out this box up here with your name and date. Our objective is going to be gram to gram stoichiometry. This is objective 1 in our unit 8 here, and let's get our essential question up. So our question says, given grams of one substance, how do you find grams of another substance in a chemical equation? So we're going to have a chemical equation, and we'll have one thing, and we'll need to find another. Let's get our chemical equation up. So this equation says C6H12 plus 9O2 gives 6CO2 plus 6H2O. When we look at this equation, we see a couple of things. First, there's no coefficient there, and then we've got a 9 and a 6 and a 6. And this is a combustion reaction. It ends with CO2 and H2O, and we've got this C6H12 is called hexene. And so in order for us to practice this, we need a sample question. So let's pull that up. So here's our sample question. It says if 17.2 grams of C6H12 reacts, how many grams of CO2 will be formed? Now, we can answer this question pretty easily. We can also answer a question that would be backwards of this if we wanted to know how many grams were needed to form something else. So scroll up there. So let's go through the steps here. So the first thing that we have is the grams of one substance. And in order to be able to do our mole-to-mole stoichiometry using our chemical equation, we have to have moles. So the first thing we need to do is we need to go from grams to moles of our given. So our given is that 17.2 grams of C6H12. And to go from grams to moles, we divide by the molar mass, which for this one is 84.162 grams per mole of the C6H12. So my calculator tells me that that is 0.204, and I like to keep all the numbers I can for a little while, 3677, but I'm too lazy to write them all out. So this is how many moles of C6H12 that I have. So now that I know how many moles of C6H12 I have, then I can do my next step, which is to, whoa, hello. Sorry, I'm just trying to move that. Okay, let me zoom back out. There we go. All right, so my next step that I need to do is I need to go from my moles of 1. So this will be step 2. So now I need to do my mole to mole stoichiometry that I learned in the last video, right? I'm abbreviated stoich. Okay, so I've got C6H12, but I want CO2. And according to my equation, there's a 1 in front of the C6H12 and a 6 in front of the CO2. So that means that I get 6 times the carbon dioxide of 6 times the moles of carbon dioxide than I had of that C6H12, which is hexene. So what I really need to do is I need to look at my number here. So I have 0.2043677, and hopefully it's a little obvious that I'm really just going to have 6 times that for my moles of CO2. So when I plug that into my calculator, my moles of CO2 is 1.226206 moles of CO2. So now I have the moles of CO2, but I'm asked to find the grams of CO2, so there's one last thing for me to do, and that is to go from moles to grams, that's an arrow, and that's a G, to grams of what I'm going to call my answer. So I have moles of CO2, 1.226206 moles of CO2. And to get to grams, I'm going to multiply by the molar mass. And the molar mass for CO2 is 44.009. grams per mole, CO2. And when I multiply those together in my handy calculator, I get, I'm going to put it blue here, I get 53.96, that's a 941 grams. Now, in general, questions are probably going to ask you, especially on the quiz, they're going to ask you to round to 2 digits, so let's talk about that briefly. This would be the second digit past the decimal place, so what tells me whether or not I round is this 4 right here. That 4 tells me to stay, so then I'm just going to drop those numbers, 53.96. Now, the rest of the numbers don't matter. I'm just looking at that very last number. I don't have to do anything with the 9 because it's in front of the 6. So the answer here is 53.96 grams of CO2. All right, so if you need more practice or you'd like to see more examples, please let me know. I'll be happy to walk through some with you. But that concludes our session about gram to gram conversions. Thank you.